Hey guys, welcome back. Today I've got an update on this guy. So I know some of you have been waiting rather impatiently for an update, so I figured it was time enough to do one. So if I can take this apart again, it's not easy to pull apart, especially since I smashed it down pretty hard last time. The struggle is real. Go. I gotta pull the front out. There we go. Okay, so to build this, I have to first figure out, at least, well, the way I feel like doing it, is I need to figure out how to mount this motor in this boat. So I kind of want to put weight centralized. And I also need to mount this kind of far enough forward because when the drive shaft comes out like this, I want it to stick out the back quite a bit so we can get a good angle and have it go deep underwater. I need the propeller to be under the water line, which will be very close to the bottom here. So it's going to stick out a little bit, and we need to put this up and far enough so that the angle's not too bad and be able to, probably, the drive shaft's probably going to go out to about here maybe. And the motor, I'd like it maybe centered, yeah, maybe like that, something like this. So we need to build something, a mount that'll go up high enough that I can glue to the bottom, that'll have some tool access on this side, and that it'll all work together. So I figure this is as good a time as any to test out some CADing skills, because I do have a 3D printer. I will design my first ever part and print it out, and we'll see how it goes. So yeah, I think I'm going to give that a shot, make a motor mount, something sturdy, holds up the motor high enough, and we'll go from there. So for this I thought I'd try Tinkercad, because Tinkercad is a free bit of software, and I do like free. It's also web-based, so you can use it yourself. You don't have to download anything. So the very first thing I want to do is I'm making the face where the motor will actually mount, which is really nice because you could just select these cylinders, and I have a big orange cylinder that is actually a part, and then the little gray cylinders, which are actually holes. And I'm just kind of making sure everything's lined up here. Now I'm going to take another a tube this time, because I know I have the front cylinder where my motor will bolt to, but now I need to give it a little bit of structure. So here I am just pulling it up, making it taller. I'm going to make a block now, which is a hole, so I'm subtracting material. And I kind of want to give this a nice curve. I want the motor to be able to breathe. It has to have access to some air because the motor will get hot. But at the same time, I want it to be solidly mounted. There I am, just lining them up together. Just trying to check the alignment here. I'm not too familiar with these tools, but it's not too bad. Here I am just adjusting the wall thickness. I felt like the wall was a bit too thick. I do know that my printer prints a bit bigger than it should, so I need a lot of space to be able to bolt the motor up. Now I need to make a base, and this is my first mistake, is I didn't line up this red piece, this red square piece, to be equal in the middle. I just eyeballed it, and you'll see my part will be a little bit off later on. So here I'm making a gusset. I want to be able to make this a strong part. And I'm not too worried about how much volume the part is, because the beauty with 3D printing is you just have to adjust the infill percentage. You don't have to worry about having too much material there. They're making a flat section. I need a big flat section because I want to be able to glue this to the bottom. So here I am stretching out both sides. And there I joined everything together. And there you can see on the left on the left there, there's a little bit more of the circle protruding into the triangle. So I think that's my mistake. Here's the time lapse of the 3D print. This is on a Tron XY X3A printer. Everything is stock. In fact, I haven't even finished making the wires all tucked in nicely. So here it goes. It actually took maybe 2.5 hours. This is just a time-lapse shot with my D7000. I think it's a photo every 30 seconds. Here it comes up the ways a bit. You can tell on that base there, you can see the grid pattern. That's the infill. Almost done here. It's actually very interesting to watch a time lapse because in real time it goes very slowly. Almost done. Just going to cap off the end. And there we go. Print is now finished. Let's take a look at that. And here it is. This is the completed 3D printed part. There's a little bit of the surround here to make it adhere to the bed. The finish on the face isn't too great because I have painter's tape put on the face, on the bed I mean, and I think I want to upgrade to tempered glass, so that's probably coming in the future. But the best part about this part is that it freaking fits. This is literally the first CAD I did. This is the first print I've done of it, and everything works first try. So I'm going to put this through here. This motor fits through there. I got to rotate this for the screw holes to align. Oh, here it goes. I'm going to snap these screws in. This is just literally, I used a pair of digital calipers and I measured my parts out, and then I just made what I saw in the calipers onto the screen. Just took the settings, put this up into my slicing software, and it freaking worked. Look at that. The motor has a little bit of breathing space all the way around, very little bit, but breathing space up here for sure. The wires are sticking straight out, and this will fit on the boat. So I just need to trim this part up, maybe sand it a little bit around the corners so that it fits up better, and then I'll show you what that looks like on the boat. Alright, so let me trim this up and I'll bring you back. And here it is, all cleaned up. No more sharp edges. That's the only thing I find with when you do the brim for adhesion. It usually leaves a little bit of a sharp edge. Clean that all up with some a sanding stick. These are like nail files from the dollar store. And yeah, it looks pretty good. I'm really happy with the part. I'm really happy with the finish. I knew that the holes would be a little bit smaller because I think my printer tends to over extrude, so put down more material than is necessary. So I definitely made the holes a little bit bigger, and I figured if there's a little bit of wiggle room, it's not the end of the world. I like the pedestal. Pedestal's nice. It sets this up a little bit, although it is offset. If you see right there, you see that the whole thing is shifted over this way. So it's not the end of the world, but something to watch for next time. These walls are pretty thick. I think I did infill was 40%, I believe, and the wall thickness was 3 passes because I wanted this to be nice and rigid, and this thing is sturdy. I don't think I'll be able to break it by hand, and so the forces experienced by the motor won't be too bad. And how much does this weigh? That is a good question. This weighs roughly, I don't know if you can see that, 29 grams. So it weighs basically nothing. 29 grams is negligible when you're looking at a displacement hull. And so let's put the motor into this again and put this on, or in the boat where we think it's going to line up. And then I need to talk to you about one more thing. Put this in nice and tight. Okay, that's not going anywhere. This spins no problem. And here's the boat. We're going to have this, I think, roughly here. It is a little bit of an aggressive drive shaft angle, so it may have to go a little bit more forward. You can see there. Yeah, not too bad. So I'll have to figure out how to remove this gear. I may be able to slip the universal joint right onto this and forget about the gear, or mount this backwards and actually have it sitting on this end of the shaft, which would work too. It wouldn't matter. Although I would like the bolts to be able to be reached really easily. And so the last thing is the drive shaft. Now the drive shaft is a problem. I did try to order a drive shaft from eBay, like a pre-made one, but that didn't work out because Canada Post right now is on strike. And so I can't really order a drive shaft. Canada Post won't accept outside deliveries anymore until the strike is over. So I went down to the hobby shop and I got these. So what this is, let me see here. 3.18 millimeter brass rod, which I'm hoping to use as the drive shaft itself. And then, I don't know if you can see this, but this is a brass tube. And this is 3.97 millimeters outside diameter and 0.355 millimeters wall thickness, which makes the interior almost exactly the same size as my rod. So if I can stick these together, they do fit quite nicely. But this does pose a problem. You see, I need to tap threads in the end of this rod. See, there we go. Nice, perfect fit. So even this full length, I can still rotate this pretty freely. So I need to tap holes, or tap a thread at the end here to make a drive shaft, or to make threads to thread on the propeller. But it's an M3 thread, so that means metric 3 mils, which means that it should be around 2.9 millimeters in thickness, and this is 3.2 millimeters. So I'll have to figure out a way to trim this down, to turn it down a little bit thinner, and then cut threads, and then put the prop on, and then make sure I can cut this tube to length, cut this shaft to length, and then I think we'll have a working drive shaft. I think that'll be a video of its own though, and I think this will be enough for today's update. So thank you very much for being patient with me while I build this. For sure, 100%, unless there's some sort of natural disaster happening around here, this will be done by spring. So we're going to keep working on it. If you're excited to see more updates, then let me know in the comments below. Until then, thanks for watching.